Hi guys, welcome to my channel. This is Shashidhar Mali, studying in SVC Bengaluru from Department of Electronics and Communication, section Astrosat, subject Electronic Principle and Circuits, course code DEC 303, semester 3rd semester. In this video, I am going to discuss the concept of loading effect impact on the input impedance of a circuit and equation for an input voltage common emitter amplifier circuit, AC equivalent circuit, and effect of a input impedance. Loading effect impact on the input impedance. Understanding the loading effect is a critical concept in design and analysis of electronic circuits. The loading effect refers to the influence of a connect component on the input impedance of a circuit, which can significantly impact the intended performance of a circuit. The loading can be caused by various factors such as internal resistance and capacitance of a connected component, the characteristic of a circuits, and the frequency of a input signal. Introduction to input impedance and the loading effect. First one, input impedance. Input impedance is a opposition of a circuit present to flow of a current at its input terminal. It is expressed in ohms. Then second one, loading effect. The loading effect occurs when a connected circuit or a device known as the load draws a current from the source alternating the input impedance of the original circuit. Then third one, impact. This alternation can affect the voltage levels and current flow within the original circuit, potentially impacting its intended function and performance. Then coming to the concept of a input impedance. Definition. Input impedance is the resistance offered by a circuit to the flow of a alternating current at its input terminals. It determines how much current the circuit will draw from the circuit. Then measurement. Input impedance can be measured using the ohmmeter or by analyzing the voltage and current at the input terminals. Then input impedance significance. Input impedance play a crucial role in matching the source to the load, ensuring a efficient power transfer and optimal performance for an electrical circuit. Factors affecting the input impedance. Components. Resistors affect the input impedance, capacitor affect the input impedance, and also inductor affect the input impedance. Circuit configuration. Series and parallel connections are also affect the input impedance. Transistor configurations. Feedback networks. Frequency. Capacitors and inductors exhibits a frequency-dependent impedance. Input impedance can vary with the frequency of the signal. Derivation of the input impedance equation. To derive the input impedance, impedance of a resistor. The impedance of a resistor is a simplest resistance value R. Impedance of a capacitor. The impedance of a capacitor is inversely proportional to the frequency. Then impedance of an inductor. The impedance of an inductor is directly proportional to the frequency. The loading effect on a input impedance. Initial input impedance. The circuit initially has a specific input impedance before the load is connected. Connecting the load. When the load is connected to the circuit, it draws a current from the source, affecting the current flow in a circuit. Then altered input impedance. The current drawn by the load alter the input impedance of a circuit, potentially reducing it or increasing it depending on the load's characteristics. Impact of the loading effect on the circuit and its performance. When reduced voltage, the voltage at the input terminals can be decreased due to the current drawn by the load. Signal distortion. The loading effect can be altered the waveforms of a signal, introducing the distortion and affecting its fidelity. Power loss. The current drawn by the load can cause a power dissipation within the circuit, reducing the power delivered to the load. Equation for a input voltage in a common emitter amplifier circuit. Input voltage. The input voltage Vin of a common emitter amplifier is determined by the voltage divider formed by the input resistance Rin and the base resistance Rb. The equation is Vin equal to Rb by Rin plus Rb whole into Vcc. AC equivalent circuit of the common emitter amplifier. Then first one, hybrid pi model. The transistor is replaced by the simplified model, which includes parameters like a transconductance, input resistance, and output resistance, representing the transistor behavior for a AC signal. And second one, capacitors. Capacitors representing the bypass and coupling are included to block a DC signals and allow only AC signal to pass through it. And third one, input and output impedance. The input and output impedance are representing as the resistance showing the circuit's opposition to the AC signals at the input and output terminals. Then coming to last part of this video, effect of a input impedance on the common emitter amplifier. First one, voltage gain. A higher input impedance generally leads to the higher voltage gain for the amplifier, as it minimizes the voltage drop across the input resistance. Then second one, signal distortion. A low input impedance can be cause signal distortion due to the voltage division at the input, resulting in an attenuated signal reaching the transistor. Then third one, circuit stability. The input impedance of the common emitter amplifier can affect the circuit stability, particularly in a high frequency application where a parasitic capacitance can play a significant role. Thank you. If you are new to my channel, please like, share and subscribe.